In 2011, a team of divers off the coast of California noticed a humpback whale tangled in hundreds of feet of crab trap line. The ropes were wrapped around her mouth, her fins, her tail. She was exhausted. She was drowning in slow motion. The divers went in anyway. They spent over an hour cutting her free, working around a 45-ton animal that could have killed any one of them with a single reflex movement. And when the last rope finally came loose, the whale didn't flee. She swam in wide circles around each diver, one by one. She nudged them, gently, deliberately. The lead diver said it was the most powerful moment of his life. Most people watch that and feel something immediate. She was saying thank you. That's what it looks like. That's what it feels like. But here's the uncomfortable question science actually asks. Did she know he was helping her? Or was something else entirely happening inside that massive, ancient brain? The answer isn't what you'd expect, and it cuts much deeper than gratitude. Start with what happens inside a wild animal the moment a human gets close. Every wild animal carries what biologists call a threat response system. It's not a choice. It's not a personality. It's a cascade of automatic physiological states that fire in sequence the moment danger registers. Your distance from the animal determines which state activates. Too close, and the system escalates, one stage at a time, until the animal has no options left. The first stage is freezing, not the panicked kind. A precise, deliberate stillness. Heart rate drops, breathing slows, every sense sharpens. The animal isn't paralyzed, it's reading everything, calculating. This is an active state, not a passive one. If the threat keeps closing in, the system shifts, fight or flight. Heart rate spikes, adrenaline floods the bloodstream. Every muscle loads for explosive movement. And then, if escape is completely impossible, if the animal is pinned or cornered or physically held, something stranger happens. The system trips a last resort switch that most people have never heard of. It's called tonic immobility, and it is nothing like sleep. The animal goes rigid, completely still. To any observer, it looks unconscious, but EEG recordings tell a different story. The brain is fully awake. Cortisol is spiking. Heart rate is elevated. The animal is experiencing something close to the outer edge of terror, locked inside a body it can no longer control. It's a reflex so ancient it predates mammals. Your nervous system carries a version of it too, buried under hundreds of millions of years of evolution. This is what scientists have to rule out every single time they look at footage of a wild animal staying calm near a human. Is this cooperation, or is this an animal so overwhelmed it has crossed into involuntary shutdown? The answer depends entirely on which species you're looking at and what their brain is capable of. Here's where it gets genuinely strange. Some animals don't just tolerate human help, they appear to actively seek it out. And for those species, something different is happening entirely. In 2016, a young elephant in Kenya was found wandering alone, a deep gunshot wound in its shoulder from poachers. It was miles from the nearest conservation outpost, but it walked directly toward it, straight to the humans. Rangers described it as purposeful. It stood still while they treated the wound. It didn't charge. It didn't flee. When the treatment was done, it walked back into the bush. That behavior requires something specific. It requires an animal that has built, somewhere in its memory, a model of what humans are and what humans do, a representation of another species' intentions. Scientists call this theory of mind. the ability to attribute mental states to others, to understand that another individual has intentions, knowledge, and goals separate from your own. For decades, researchers believed this was uniquely human. Then the evidence started piling up. Chimpanzees have it, dolphins have it, elephants have it, and ravens, whose brains are structured nothing like a mammal's brain, have demonstrated versions of it that still make researchers uncomfortable. In a series of studies at the University of Washington, wild crows were shown to remember individual human faces for years and pass that information to their offspring. Young crows who had never encountered a specific person would mob that person based on social learning from their parents. A crow is tracking your face, building a model of your history, and updating its threat assessment every time it sees you again. That is not a reflex. That is cognition. So, when a highly cognitive animal is in distress and a human approaches, something specific happens in the brain that doesn't happen with less complex species. The threat response fires, same as always, but then a second system engages on top of it, a social evaluation system. The animal's brain begins reading the human's body language in real time: posture, movement speed, gaze direction, vocal tone. The same neural circuitry that evolved to read the intentions of other members of its own species gets redirected toward this strange, upright, slow-moving creature leaning over it. And in some cases, the threat response gets suppressed, not overridden by shutdown, actively suspended. But here's what science is still careful to say, and it matters. Calling it gratitude is almost certainly wrong. Gratitude is a complex cognitive construct. It requires understanding that someone else chose to help you, that they had other options, that the outcome would have been worse without their intervention. It requires language structures that most animals simply do not have. What looks like a whale saying thank you is almost certainly something different on the inside. Relief, arousal drop, the sudden absence of a threat that had been building for hours. But here's the part that gets uncomfortable. Different doesn't mean less real. Modern behavioral science has largely abandoned the idea that animal emotions are identical to human emotions